Okay, Kyler, could you read this one?
Potentiometer P is adjusted until oscillations just start to grow. As the oscillations grow, the diodes start to conduct, causing the effective resistance between A and B to decrease. Equilibrium will be reached at the output amplitude that causes the loop gain to exactly unity. The output amplitude can be varied by adjusting potentiometer P.
Causes.
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 Cause.
Cause.
Cause is.
Cause is.
So this is the potentiometer to adjust the resistance of this one. Then VO here and VA and VB here. And here. Why do we need to make the loop gain to be 1?
To have the same output and input.
Huh?
The same output and input.
Kyler, why loop gain should be 1?
To achieve the equilibrium.
Kumel, why loop gain should be 1?
I need to balance this as well.
Lai, why loop gain should be 1?
Exactly, the input the same as output.
Okay, why loop gain should be 1? I mean, why loop gain should be 1? In this case, why? This is what it is.
震荡，
So why loop gain should be 1?
震荡是要在就是正一为一的时候才会震荡。
Use English.
Oscillator work when the loop gain is 1.
Okay, good. Remember, this is oscillator. If loop gain is 1, then if there's no oscillation, it's useless for loop gain to be 1. We need to make the diode to conduct. So P is adjusted until oscillations we start to have oscillation. The diode, this is a diode. This one is a diode. This one is a diode. So we have this exercise. Kumil, could you read this exercise?
For the circuit in figure, find the following in the setting of potentiometer P
oscillation just start, the frequency of oscillation.
Okay. So remember, loop gain 1 is the oscillation condition. Then we need to adjust P to change this 50 k ohm potentiometer. See, P adjusted as the oscillation grows, diode start to conduct. So diode starts to conduct, causing the effective resistance between A and B. A and B to decrease. See, if they are not conduct, we have 10 k ohm, but they start to conduct, means their effective resistance decreases. Okay, so please do this exercise. Okay, so the circuit is very similar to this one. Then the closed loop gain. So if we ignore this one, look at this circuit. This is an oscillator. VO divided by VA is the closed loop gain. You can prove this one is a solution. For this circuit to oscillate, R2 divided by R1, R2 divided by R1, because the loop gain should be equal to 1. So no imaginary part. Then R2 divided by R1 should be equal to 2. 1 plus 2, 3. This is 3. So the loop gain will be 1. So this is the case for oscillator to work. Then R2 divided by R1 should be equal to 2. You come to this one. So remove D1, D2, remove this one. Then for this circuit to be an oscillator, R2 divided by R1 should be equal to 2. So this potentiometer should be placed at this point. So the left-hand side is 20K, the right-hand side is 30K. So 30K plus 10K is 40K. 40K divided by 2K is 2. So that's why the potentiometer should be put here and the ground. For this point to the ground should be 20K. So this is the reason. But now, if A is output is an oscillator, so B must be an oscillator. So this is the reason. So do you get it? Okay, good. And you can get VB as a Hugh, do you understand?
Yes.
Can you, turn it off?
Circuit oscillates at the frequency for which the phase shift of the RC network is 180 degree. Only at this frequency will the total phase shift around the loop be 0 degree or 360 degree.
That's good. Can you explain?
Circuit can oscillate if the phase shift will be 180 degree.
Why? I don't understand. Could you explain to me?
The condition for circuit to oscillate is that the phase shift must be 180, 0 degree or 180, 360 degree.
Why? Why? Can you explain the second sentence?
At this frequency, the total phase shift will be 0 degree or 360 degree.
Why?
Because it is in circuit oscillator said this.
Why? Can you come here, explain this? Do you know the answer?
No.
Cool, ma'am. Okay, can you go back?
When we have a phase shift of RC 180 degree, so at that time circuit will oscillate. Then after, if we want to achieve this, then this K, it should be slight greater than inverse of this magnitude of the inverse of this RC circuit.
The RC circuit, why it should be 180 degree? Why? For this one to be an oscillator, why this RC network, the phase should be 180 degree? Why?
Because only at this frequency we will get the oscillations. It will
Why?
overlap in
Why?
sequence 360.
Why loop gain should be 1? And why the phase of this one, this RC network, the phase should be 180 degree. The loop gain should be 1. Loop gain should be 1, number 1. So what's the phase of number 1?
180.
Number 1, what's the phase angle of this number 1? Go back. Okay. What's the phase angle of number 1? Huh?
Zero.
Yes. So for the phase of this circuit to be 0, and this is minus k. K is a positive number. So can you explain why the RC phase is 180 degree? 阿米。阿焕
K 是 180，然后
，K is a positive number.
前面那块跟后面的相加等于
Why? K is a positive number, and we have minus sign
所
here.
以前面那块蓝色的要减掉，后面那块这是角度，
OK，博全。
前面是180度，然后后面180度，
Yes,
所以回来
this is minus number. A positive number, the phase angle is 0 degree. So look at this real axis, imaginary axis. Positive number, phase angle 0. Pure imaginary positive number, phase angle 90. Pure real number, negative, phase angle 180 degree. If the RC circuit has phase angle 180, this number times this number, phase gain. So phase gain equal to two number multiplied their phase angle. Phase angle, we add the two phase angle. So if this is minus 180, minus K is minus 1, it's 180. This is 180. 180 plus 180 equal to 360. Kaiser, explain to me.
I didn't understand.
You don't understand? Hugh. Okay, Bochuan, you are in charge. Make sure everyone understand this one. After everyone understand this one, ask Kaiser to knock my door. Okay, camera off. Ready? Yes, Ami,
Yeah.
could you explain?
对，因为振荡器的那个
English, please.
the oscillator need to work in 0 or 360. So the K is 180.
Wow, you mean K?
Yeah, K is positive.
K is positive.
Yeah.
So what?
So the phase
Huh?
is
K is 180.
no K is a K is a number and the K phase is 180.
Negative. K is a positive number. So what's the phase angle of K?
0.
Okay. Okay, continue.
So
Okay, from start again.
the oscillator need to work in 0 and 360, and the K is a positive number and its phase is 0, and E have minus sign, so phase is 180.
Can you repeat? K is a positive number, so phase angle is 0. Okay, then okay, continue.
And E
What? E.
it has
It,
yeah,
it has. What is it? Which one it?
the K
K is positive number.
yeah,
Okay, so, okay, then, okay, continue.
and it has minus sign,
Okay,
so the phase is 180.
okay,
And the RC plus RC times K need to 0 or 360, so the phase RC need to be 180.
okay. Awan, could you read the second one?
for oscillation to be sustained
why k should be equal to the inverse of the magnitude of the RC network transfer function. Comment, why?
Because oscillator work on the positive feedback, so we need K positive. If we get the positive feedback, so we will get a 360 phase shift.
Okay, Roger. Why? K should be equal to the inverse of the magnitude of the RC network transfer function.
因为这样它才能符合那个
English.
because this can fit the Barkhausen rule. Yeah. Barkhausen rule, one is gain equal to one, and the second is the total phase need 0 degree or 360 degree.
This is gain A, this is feedback gain beta. So beta times A, magnitude should be 1, phase angle should be 0. So beta times A, magnitude should be 1. The magnitude of the K and RC network transfer function magnitude, RC magnitude. So K should be inverse. So RC magnitude inverse is 1 over RC magnitude. So 1 over RC magnitude times RC magnitude. RC magnitude cancel out equal to 1. Okay, can you explain again?
The RC is the beta and the gain times beta need to equal to 1 and the phase equal 0. So
Hugh.
The gain value should be equal 1, and K times the RC should be 1, and RC, if we have RC value is positive, for example, is 1 over E2, and the K value should be reversed is 1 over 2, and 2 times 1 over 2 and value 1.
Okay, so magnitude of RC transfer function. It can be a real number or imaginary number. So the magnitude of RC network is square root if RC transfer function equal to A plus Bj. The magnitude of RC transfer function is square root A squared plus B squared. So this is the definition of magnitude of an imaginary number, a complex number. So complex number is A plus Bj. Because RC network transfer function should be a complex number. But anyway, magnitude of RC times magnitude of the gain A. The gain A equal minus K, so magnitude of, so if A is the gain equal to minus K, K is a positive number. So what is the magnitude of the gain A? Comment. A gain equal to minus K. We take absolute value of A. So what is the absolute value of A? A equal to minus K, what is the absolute value of A? K is a positive number. Kyler. Hugh.
A equal K.
Yes. Can you explain to Kaiser and Kuhlman? Okay. Kaiser, could you read the third one?
To ensure that oscillations start, the value of K has to be chosen slightly higher than the value that satisfies the unity loop gain condition. Oscillations will then grow in magnitude until limited by some non-linear control mechanism.
Okay. So you have proved this point. I ask you to prove this one. Here, Kyler, could you read this again?
To ensure that oscillations will start, one choose R2 divided by R1 slightly greater than 2. The reader can easily verify that if ratio of R2 and R1 is 2 plus delta, where delta is a small number, the roots of characteristic equation 1 minus L of S is equal to 0 will be in the right half of the S plane.
Yes. This is the same as this one. The gain, open loop gain. If you can use this, did you do this, Kyler? Did you do this exercise? Did you do it?
Yeah, maybe last time.
Maybe.
Yeah.
Kumil, did you do this one?
We have
You have done this one? So do you remember how to do this?
yeah, I will do it.
You remember?
Yeah, I will try. I will do it.
Did you do it?
Yeah, I had.
But do you remember how to do it?
I don't remember exactly.
You don't remember.
Exactly.
Then did you do it by yourself? But now you don't have competence to do this by yourself.
What I have to do? I
Huh?
will do it. What I have to do?
So you have proved this one by yourself. Hugh, did you do this?
Yes.
Did you do this by yourself or you copy other people's answer?
I cannot do it by myself, so I prefer to the other people.
You copy theirs
With help from the other people.
with the help from them.
Yeah, not copy.
So who did the answer? By who can do this problem? Who? Huh? So you did by yourself. Okay. In order to have the slightly, we put this delta small positive number. So if this is a small positive greater than 2, you can prove the pole is on the right half plane. Which is this point. Okay, Kyler, could you read this one?
To start oscillations, RF has to be made slightly greater than the minimum required value, although the circuit stabilizes more rapidly and provides sine waves with more stable amplitude. If RF is made much larger than this minimum, the price paid is an increased output distortion.
Okay. RC. So this is the RC feedback network. We have so this one, D1, D2, R1, R2, R3, R4. is the nonlinear limiter, the control to make the oscillation won't grow too large. So these are the limiter. And this one is the RC network plus the gain to create the oscillation. So RF value is here. So this is the phase shift oscillator. The phase shift oscillator. So in order to confirm this is an oscillator, this is the exercise 17.5. So we can prove this is an oscillator. Then for this one to be oscillator, you need to find the loop gain first, then get the transfer function. So, Kumio, could you read the first one, the first point?
Consider the circuit without the limiter, break the feedback loop at X, and find the loop gain.
Okay, first, we don't consider the limiter. And we break the circuit here. So this is the input. So this is output. And this one is RF. So calculate the loop gain beta A beta A equal to this. This is the beta A loop gain. And Kumio, could you read the second one?
It's easier to start at the output and work backward, finding the various currents and voltages, and eventually Vx in terms of Vu.
Okay. Please start this. Okay, thank you.